ladies and gentlemen.
Let's talk systems of linear inequalities. So the major difference between a system of equations and a system of inequalities is an equation has one solution typically where the two lines would intersect. They could have none if the lines are parallel and are not the same. If they are parallel and the same, that makes them infinitely many solutions, but only along the line they share. For a system of inequalities, we still typically have an intersection point, but we also have a shaded region. So if I cross my arms like this, I have four major regions that it could be, and it could be any of those four regions that represent our solution region. Therefore, every point that falls in that region would be a solution to our system. So let's look at an example, shall we? So we have this system of inequalities here, and we can see that the vertical line is dashed in all of them because we are not equal to, and the slanted line is solid because we are equal to. We're just trying to figure out which region it falls in. So what we're going to do is we're going to test a point, and I always try to start with the easiest point possible, 0, 0, if it's not on the line. If it's on a line, we can't pick it, but I'm always going to try to start with 0, 0. So if we plug it in, is 0 greater than or equal to 0 plus 1? No. But is 0 less than 2? Yes. So it works for the vertical line, but it doesn't work for the slanted one. So that means that we are on this side of the graph. Oh, that might be a little hard to see. We are on this side of the graph for the vertical line, but we are not on this side of the graph for the slanted one. So what does that mean? It's C. It has to be up here. And we can try out a point from that region to double check. It's always good to double check. There we are. So let's erase and plug in a point in this region. I spy with my little eye that 3, 0 works, or 0, 3, my bad. 0 for the x, 3 for the y, so 3, that's also hard to see. Let's switch that one. 3 is greater than or equal to 0 plus 1, that is true. And then 0 is less than 2, also true, so that is why C would work. Same idea, if we have which of the following coordinates is a solution set to this, we're going to plug in and see if it works. So do keep in mind that both of these are strictly greater than or strictly less than, so no equal to at all. So let's try out 0, 0, because that's always the easiest one to use. Is 0 greater than 2 times 0? That is not a true statement. But is 0 less than 2? That is a true statement. So this point works for the second one, but not the first one. So we need to somehow get the x's to be less than the y's. And I think this one might be our goal there. So try it again. 0 is greater than 2 times negative 1. 0 is greater than negative 2. That is a true statement. And then 0 is less than 2. That is also a true statement. So it is this one. So you don't have to test all four of them. You can kind of narrow it down based off of the information that you know and how your first test went. Last but not least is a word problem. So Central University requires a college admission test for all incoming freshmen majoring in science. Students must take a mathematics and a science test. The maximum score of the combined test is 500, and students are required to make at least 170 on the mathematics portion, or the mathematics section. Write a system of inequalities to represent the possible values a student can score. So we're not trying to solve anything, we're just writing what it could be. So we have math and science being talked about as scores, so let's use M and S. M plus S together has a maximum score of 500, so it can be 500, but it can be less, can't be more. And the students are required to have a minimum, or at least 170. So the math has to be at least greater than or equal to 170. That is all the information we have, so those are the only inequalities we can write, so that would be our system. There we go. If you have any questions, let me know. Otherwise, I'll see you in the next video.